Hi all, so remember how week 6 was pretty light? It's done now. Week 7 has a bunch of stuff for you guys to do. Whew, I feel bad, but that is how it is. I guess, something different. At least a lot of it, even though it looks pretty extensive, is pretty repetitive. So you're going to have 2 labs this week effectively. Please submit them as separate Word documents. You can upload them at the same time, but just save them separately. That makes my life easier as the grader. I have no idea which one I'll grade first. It just kind of depends on my mood. But you'll click on here to get the one for the phenotype and genotype, which is nicely spelled incorrectly. And the genotypes and genetics lab report will be here. You also want to click on all these suckers and download them, as they will be part of what you have to do for the lab. Okay. When we click on my post, as always, you can feel free to share your observation post. Tables is the word I'm looking for, and then the link that you must have clicked on to see this video, and then down here is going to be the rubric. So let me pause this and open that. Here we go. Here's the rubric for the last set of labs. You can see we're back down to tiny amounts of points to get everything done. There is a bunch of stuff going on. Oh, I feel bad that it's your last week, and I feel bad that I have to grade it. But you know what? We're going to do it. We're going to learn amazing things and be awesomeness, right? Remember that I do want to see those complete sentence grammar and correct citations. It is telling you that you basically get format and citations graded for each lab separately. It just makes life easier. Make sure you do have a full reference and incorrect citations and a title page on each lab, because there is nothing more obnoxious for me than in week 7 to have to dock you on stupid things. So if you haven't been getting 100% on that stuff, submit a draft, right? And tell me when you submit a draft, like, hey, I just want to get 100% on this, and I will try my darndest to help you. Okay, so let's go through the human genetic ones first. So in here, you're going to put in your genotypes for all the various things. If you are dominant, unlike this, you will have 2 options, right? So if you were dominant, you would have 2 big letters and a big letter and a little letter. If you are recessive, you will only have a little letters. And the offspring, if you are dominant, you will have to do it for each version of what you might be. So, if you have a third eye and that is dominant, we'll say it's capital T for third. You'd have to say if parent 2 is big T, this is what the kids will be. If parent 2 is big T, this is what the kids would be. Well, if you didn't have that third eye, you would be little t, and you wouldn't have to put that little note in there. You want to tell me everything. In here, make sure you tell me the phenotype and the genotype. So like here you see the phenotype and the genotype. Do all that. Okay, and you'll do that for all of them. If you don't do it, I'll be knocking points. See, it goes down, goes down, goes down. And this will be a percent in offspring. So you'll have this many big D, this many big L, little L's, this many L, little L's, this many big L's, depending on what your genotypes are, right? So in the table, it shows you how you do it. You're parent 2, so you'll be changing that stuff. If you don't use a table, like say you'd only need 1 because you're recessive in here, just go like this. And then that table is done, okay? It just lets me know in /A you didn't need it, so you didn't need it. All right, I'll do it for everybody. Yay, more. With luck, you have lots of recessives, a little less work. So as parent 2, you're going to tell me how many recessive traits you had, what were they, how many dominant traits you had, what were they. Then you're going to look at a actual genetic trait that can be monitored by parents that are going to create offspring, right? So what's something that you might want to be aware of and to be looked at, and why would you want to monitor it? Why do you want to be aware of it, right? So look for that. So that was probably where you're going to get our source, right? Because you need to look up at somebody. Then in here, this is when you have your disorders for those things you downloaded. You're going to give me an image, take a photo of what you did, and give it here. And then you'll tell me what the 2 disorders are. Here they nicely gave you the karyotype. You're going to tell me what the name of it is, what the genotype of it is, and what the phenotype of it is. In here, it is very common for people to forget to have in-text citations and directly cite the lab manual. Paraphrase and have your in-text citation, okay? I don't need it so much for the name or the genotype, but I need it for the phenotype. Just in general, if you're going to quote or cite more than 5 words, my phone is just going off, more than 5 words, make sure that you do have that in-text citation in there, because you need that whether you quote or paraphrase. With quotations, you put the quotes around it and in text. With paraphrasing, just in text. Okay, so let's look at the questions. So describe a karyotype and how it is performed. When you're describing it and how it's performed, think about how it is most commonly performed. What is going on? What is the test called? Who's doing it? Include that. Would a normal karyotype mean that a person would not have any disorder or disease in their life? And blah, 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 to give me the definition of genetics. So if you have everything genetically fine, could you still get something else? Like, what's the role of, nurture versus nature, all that stuff. We should have been talking about some of this in our class discussions, but we'll see. Okay, so then we have the next lab, which is genetics and genomics. I think of it as GG in my brain. I read the other one as HG. You'll learn. All right, so here it tells you with the dominant and the recessive. So you're going to read the case study, which I really like. You're going to give the mom's genotype and the dad's genotype, okay? Which it will tell you from here. Then put the dad up here, the mom down here, what the kids will look like. You're going to do the same thing here. Make sure you read everything really carefully. You understand all the words. People get some of this really confused. And here you have 2. Because they list Huntington's first, just list them first. So let's just say the mom you list her H's, whatever they are, and then her F's, and then the dad's H's and F's. Down here, make sure you have an H and F in each little slot for whatever it should be. X-linked dominant. Remember this, you will have. Remember how men and women are different in terms of X's, and then this thing here would be not like a letter. It would be X, go shift 6, and then, I don't know, what do you want to call it? Blindness? Which one's this one? Yeah, like that. And then you could do the other one, if we went down here, as capital X, shift 6, lower B, okay? I tend to write these up here since it didn't tell me what they were. And you can also do this as a superscript. It's just a pain in the butt. So, And then in here, you'll see what the mom's genotype and the dad's genotype is. Remember, he's a dad. He's a little different. And then put it all in here. Then we have a bunch of questions that are all like, what's the percentage? What's the percentage? What's the percentage? So it's probably going to make sense to do that previous lab first, because then you got really good at percentages. Make sure you read everything really carefully. It's really easy to get messed up in some of this stuff. Well, really easy. Okay, so that's all those, lots and lots of percentages. And we come down here, we're going to do the pedigree. So which pedigree chart best represents the spread of hemophilia? Really look into this. Pedigrees are a pain in the butt, and I need you to have it all correct. So you need to have it perfect. Luckily, it's not worth too many points if you mess up, right? Oh, let me pause this for 1 second. Okay, I am back. We did all this stuff, right? Yeah. So let's go down back to pedigrees. So make sure you're really careful with the pedigrees. You do have to have everything perfect. When it says the chart would differ, how would the chart differ? You need to talk about the percent of kids that are male, what happens to them, or I guess divide up what happens to them, who would have the disease and not. And then for females, what would happen to them? Disease carriers, not having the disease, that kind of thing. Percentages for everything, right? And then let's go down to the next one. Another karyotype that's done to you. Again, genotype, chromosomal disorder. So what is like the XYs of the situation? This one is what is the name of that, and the phenotype. For the phenotype, make sure that you are discussing, because you're going to have more than 4 words, so have that in-text citation in there. And you do that for all of those. Then you say, how is an individual chromosomes karyotype? So talk about, like, this is a little bit more on the sciencey end than the procedure that is done on it. So how you do it, but feel free to talk about procedures too. How does non-disjunction occur? So you want to tell me, how does it, and like what stage does it happen at? So where does non-disjunction occur? And then what happens to the gametes that are a product of non-disjunction? all seems to come in through the same thing. I would probably say what non-disjunction is too, you know. So like I would define it, say what stage or stages it happens at, and then what is the result of it happening at those various stages. And then we have our Human Genome Project. So in here, you're going to list your sources. I would just do the full references in here. You're going to still have the reference section at the end of the page, at the end of the labs for both labs, right? But just take your full references in here. About the Human Genome Project, have a good sized paragraph, so about 5 or so sentences at least, hitting the main points, and you should have in-text citations for the references that you put up here, okay? Approximately how many genes are present in the human body. This should be based off of the Human Genome Project's results. And I'm kind of looking for a specific number. As long as you're in the range, I'm pretty happy. How has the Human Genome Project impacted human medicine? Give me at least one real example. Okay? And then you would insert and put your reference page. Hopefully that wasn't too random with my big long break in the center, which to you seems not at all, and I was gone like getting my car for 2 hours. So here's the last lab. I feel like you guys can do this. I know Punnett squares are a little confusing. Just stick stuff in, kind of build it out. You know, you just think, what's the father's genotypes, what's the mother's genotypes, and you just drop them in. Just drop them both in, drop them both in. And then you just look. It's really nice when there's just 4, because you're like, if there's 4 things, how many times do you divide 100 by 4? It's like a quarter, right? There's 4 quarters in $1. You know, 25% this, 25% that, 25% this, 25% this. But not necessarily color blindness, because that's weird. So let's scroll up to somewhere that's not like that. Here, Tay-Sachs is normal. So 25, 25, 25. And then if you're talking about phenotypes, it's a little different than genotypes, right? If it's the same exact genotype, you just go, well, if I have 2 quarters, that's 50%. Woo! So think of it like that, okay? I hope this helps. As always, submit me that draft. Try to do it a little earlier if possible, because they are long labs. You can also submit me one lab at a time if that's easier. Often people will submit me like one day the GG lab and the next day like the HG lab. Whatever works for you is fine. I'm scrolling all the way up to see if I forgot anything. I feel like that's all the main points. Okay, hope this helped. You can do this. You're almost done. Last set of labs. I know it ends kind of stressful. Last week was kind of relaxing, and now that relaxation is over, but we're marching down to the end.